hello, now we're going to talk about property 2. Property 2 is basically going to be that x to the 0 power is equal to 1, okay? And now, let me, so here, this is, I'll admit to you that when you first see this property, it might be weird, okay? But I want you to stick with me here. So what is this saying? This is saying that if I have 2 to the 0 power, that's just going to be 1. It's saying that if I have, like, let's say 3 to the 0 power, that's going to be 1 also. If I had, like, let's say negative 3 to the 0 power, that's going to be 1 also. If I have some complicated expression, 2x to the 0 power, that's going to be 1 also, okay? Now notice here I did put that in parentheses because that's kind of delicate. If it had been 2x to the 0 without the parentheses, then it would not have equaled 1. But we're going to discuss that later, okay? That has to do with the order of operations. But as written here, 2 to the x in parentheses raised to the 0 power is equal to 1, okay? So now, right now, I'm going to make an argument that, again, this is not a proof, but I want to give you enough of an argument so where you can see that this, the motivation behind this property, okay? And so that you guys can have faith when you're using it, okay? So I know that if I have, like, let's say, so let me first start by saying something important. If I were to ask you guys, what is 3 times 1? I'm sure all of you are going to say 3. No big, you're like, David, what's the big deal? If I ask you guys, what's 5 times 1? I know all of you would say 5. 1,000,000 times 1, 1,000,000, right? And what you guys are all using is the name of the property is the multiplicative identity property of 1. 1 is the multiplicative identity of the real numbers, and that's the property that we're taking advantage of when we say 3 times 1 is 3, when we say that 1,000,000 times 1 is 1,000,000. You name the number times 1, as long as that number is real, that's 1. 0 times 1 is 0, right? Now, having said this, I hope that all of you will accept that if I were to ask you what is x to the 1, which is a real number, right, times 1 will equal to x to the n. Okay? Whatever x to the n is, if I multiply it by 1, I get x to the n. Okay? But I want you guys to recall something. We just showed that x to the a times x to the b is equal to x to the a plus b, right? So watch this. If I have x to the n times x to the 0 power, what am I going to get? Well, if I take advantage of that property, I'm going to get x to the n plus 0. But what is x to the n plus 0? X to the n plus 0 is just x to the n. Okay? Okay? Okay. So now, check this out. That means that this left-hand side of this equation being equal to x to the n, and this left-hand side being equal to x to the n, this must be equal to this. Okay? So that's x to the n times x to the 0 is equal to x to the n times 1. Okay? Okay. Now, just imagine, if I have a number, like let's say x to the n were 2, okay? If this was 2, and I had 2 times x to the 0 equals 2 times 1, aha, it must be that x to the 0 is equal to 1, okay? Now, I understand that I'm hand-waving here, okay? That I'm kind of like giving an idea of what's happening. And I hope I have said enough to convince all of you that this property makes sense, okay? And in any case, if we wanted to explain it more carefully, what we would say is that the real numbers have the division property. That if you have uh, like if you have a situation where you have a times b equals to a times c, and a, b, and c are real numbers, then that implies that b equals c, and therefore because x to the n and x to the 0, and because x to the n are real numbers, x to the 0 is presumably a real number, and 1 is a real number, then because of that property, we would get x not equals to 1. But I don't want to go off into this abstract situation right now. I just want to give you guys a motivational argument, okay? And because that's what's appropriate for right now. Later on, you guys can learn more of the details. In any case, I hope you guys have enjoyed property 2, and we're going to see it applied to different examples. Thank you.